Groovy Basics Part 2. This is Lecture 10 of Section 3. Let's begin. In this lecture, we will study about various data structures, namely ArrayList, list, HashTable, HashSet, map, set. Then we will study about the exceptions in Groovy, followed by a quiz in the end. ArrayList. ArrayList supports dynamic arrays that can grow as needed. In general, arrays are of a fixed length. After arrays are created, they cannot grow or shrink, which means that you must know in advance how many elements an array will hold. ArrayLists, on the other hand, are created with an initial size. When this size is exceeded, the collection is automatically enlarged. Similarly, when objects are removed, the array may shrink. Now let's see what are the various ways to create an array list. We can write an array list like def list equals to empty. This is a default array list. Then we can define def list as an array list, and then we can also write the array list keyword before the variable. That would also be an array list. So these are the various ways to define an array list. Alright, now let's talk about the functions supported by ArrayList. First of all is the add function, which inserts the specified element at the specified position indexed in this list. Then we have the boolean add, which appends the specified element to the end of the list. Then we have an add all, which appends all of the elements in the specified collection to the end of the list. Then we have another boolean add all, which inserts all of the elements in the specified collection into this list starting at the specified position. Then we have an int size function, which returns the number of elements in the list. Then we have a get method, which returns the element at the specified position in this list. Then we have a set method, which replaces the element at the specified position in the list with the specified element. Then we have an index of, which returns the index of the list of the first occurrence of the specified element, or it returns a negative one if the list does not contain the element. Then we have the last index of method, which returns the index of the list of the last occurrence of the specified element. And then we have the contains method, which returns true if this list contains the specified element. Now let's discuss the list data structure. A list is an ordered collection of objects. This is a very simple definition of a list. You can create a list as follows: def list equals to an ordered collection of objects. Notice that the square brackets is the empty list expression. So that's how you can start by creating an empty list. We can use the square brackets to assign a new empty list and this operator to append items to it. Like in this code, we have an empty list called list, and then we keep appending items to it and keep checking if the items have been added or not, and this is how the items have been added. You can also use the left shift method to add the items. Now let's discuss the various methods which can be used with the list data structure. First of all is the add all element. It modifies the list by inserting all of the elements in the specified array into the list at the specified position. Then we have a plus method, which creates a new list by inserting all of the elements in the specified array to the elements from the original list at the specified index. Then we have a max method. We can find the maximum and minimum in a collection. And then we have the remove method, We can remove an element by referring to its index. Then we have a minus method. This creates a list composed of the elements of the first list minus every occurrence of the elements of the given collection. Let's study some more methods. We have a find method which finds the first value matching the closure condition. We have the find all method which finds all the values matching the closure condition. Then we have the flatten method which flattens a collection. This collection or in any nested arrays or collections have their contents recursively added to the new collection. Then we have the sum which sums anything with the plus method. We have a clear, we can clear a list of all the elements. Then we have a pop method. We can clear a list of, we can pop the last item from a list and use the list as a simple stack. Then we have a contains all. It returns true if this condition contains all of the elements in the specified array. Then we have an isEmpty which checks if the list is empty or not. We have a count method which counts the number of elements in a list. Then we have a sort which sorts all the elements in the closure. Now let's discuss Hashtable. This is another data structure. Hashtable stores key-value pairs in a hash table. When using a hash table, we specify an object that is used as a key and the values we want linked to that key. The key is then hashed and then resulting hash code is used as the index at which the value is stored within the hash table. And this is how you create a hash table. This is the syntax. The hash table keyword, then we have the variable equals to new hash table, and then we put the values in the hash table. Hash tables are synchronized always. In this case, Zara is the key and the new double is the value of the key. Alright, apart from the methods defined by the map interface, Hashtable defines the following methods. This is clear method which resets and empties the hash table. This is the clone method which returns a duplicate of the invoking object. Then this is the contains method which returns true if some value equal to the value exists within the hash table. It returns false if the value isn't found. Contains keys returns true if some key equal to the key exists within the hash table. Returns false if the key is not found. Contains value returns true if some value equal to the value exists within the hash table, and again it returns false if the value isn't found. We have a get method. It returns the object that contains the value associated with the key. If the key is not in the hash table, a null object is returned. Is empty. Returns true if the hash table is empty. Returns false if it contains at least even one key. Keys. This returns an enumeration of the keys contained in the hash table. This is very useful. The put object, like we used in the previous slide, it inserts a key and a value into the hash table. Returns null if key isn't already in the hash table. Returns the previous value associated with the key if key is already in the hash table. Rehash. This increases the size of the hash table and rehashes all of the keys. Then we have the remove method, which removes key and its value, returns the value associated with the key. If key is not in the hash table, a null object is returned. Then we have the size, which returns the number of entries in the hash table. Now we will study hash sets. Hash set is implemented using a hash table, but the elements are not ordered. The order is not certain in the hash set. the add, remove, and contains method has constant time complexity because the elements are not ordered. This is how we create a hash set. We use the hash set keyword, and we write the variable in front of it, and then write new and hash set, and then we can use the set and add values to the hash set. Now let's study map. A map is a mapping from unique unordered keys to values. Maps can be created using the following syntax. We can construct an empty map like this and can assign values to it. Map keys are strings by default. We can also use Boolean values as keys, and we can also use null as a key. To use the value of a string as the key value of the map, simply surround the variable with the parenthesis. Adding and retrieving elements to and from the map. Okay, now how do we add and retrieve elements? You can use the property notation to get set items from the map provided with the keys or strings, which are valid Groovy identifiers. So we have an empty map, we get the size of the map, then we put this key and this value in the map, then we see the size of the map, then we get what the value of this key is, that is 5. We can also use the plus and the shift operator to add elements to the map. Note that the shift modifies the map, while plus equals to creates a new map. Getting map keys from a value, that is how you get map keys from a value. Slicing with the subscript operator. You can index into maps using the subscript expression. That is, if you have a map defined like this, you can index it to get the value of it, and you can also use a dot operator to get the value. To check the contents of the map with various methods, we have an isEmpty method to check if it's empty. Contains key 2, we have the value. We have the key, and we check if this key is available. Then we have contains value to check if this value is available in the map. Then we have remove 2, means we remove the key 2. Now we are left with this only. And then we can also clear a map. The each operator allows the map to be iterated through a closure. Now let's begin with sets. Set is an unordered collection of objects with no duplicates. So it can be considered as a list with restrictions and is often constructed from a list. A set should not contain itself as an element also, so there are absolutely no duplicates. So this is how we define a set. We write def, we write the variable, we write the array, and we write as set next to it. Most methods available to list are available to sets also, besides those that don't make sense for unordered items. Furthermore, the add and add all methods return false if the set wasn't changed as a result of the operation. We have set 1 and 2 are its elements, then we add 3, then we add 5 and 4, and then we see it returns false if they were not added. So we see in the end that yes, they were added. Now let's study the set theory concept. Union. This is the first concept. Union of two sets. This is set A, this is set B, and the union gives this set. So basically two sets A and B and a third set C, where C combines all distinct elements of both A and B. Set C would be a union of A and B. We use the plus operator to create a union between two or more sets. We can see that distinct elements were added together as set C. Then we have the symmetric difference concept. This is again set 1, this is set 2, and this is difference. Two sets A and B and a third set C, where C combines all the elements of A and B except the items existing in both A and B. So set C would be a symmetric difference between A and B, that we don't have the items that exist in both of them. So it's going to be a symmetric difference. Then we have an intersection. Two sets A and B and a third set C, where C combines only elements of A and B that exist in both A and B. Set C would be an intersection of A and B. This is part of Groovy Collections API. The intersect is the ones that are common in both the sets. Then we have complement. Two sets A and B and a third set C, where C contains all elements from A that do not also exist in B. So set C would contain the complement of A in B. If you say this differently, then set C shows what A has to offer B that B doesn't already have. So set A, give me everything in A that doesn't exist in B, and B, give me everything in D that doesn't exist in E. You can use the minus operator. Now let's study exceptions in Groovy. Handling exceptions in Groovy is the same as in Java. What are exceptions in the first place? Exceptions are events that we would normally want to handle in our program. A try and catch block is used to catch an exception and to handle the exception. But in Groovy, every exception is optional. This also goes for checked exceptions. That means you don't have to handle an exception. It is optional. You can handle an exception, and you can also choose not to handle an exception. Groovy will pass an exception to the calling code until it is handled, but we do not have to define it in our method signature. A programmer does not need to surround the method with a try and catch block when he knows that the file or any other object he is trying to access exists. Groovy gives the programmer control over the exception, so he chooses to throw one, but he does not need to. In Groovy, we can choose at which level we want to catch an exception. If we don't do anything with the exception, it will be passed to the calling code. Groovy lets the programmer decide to catch the exception or not. So this is the difference with Java. For example, in this example, the developer tries to open and read the contents of a file. He does not surround the method with a try and catch block when he knows that the file already exists. Groovy gives the programmer this control. Java would not compile the code because it expects a try and catch block that throws the exception. The example shows two ways of opening a file. One is with and without a try and catch block. When the developer knows that the file exists, as shown in the first example, he doesn't surround it with a try and catch. Later stated, the developer can choose whether he wants to catch the exception or not. Now, sometimes the code needs to catch more than one exception. So Groovy allows the developer to catch all the exceptions in one catch instead of writing a catch statement for each try block. Now, if we note that the code only throws one exception, the function open file does not exist, so it directly throws an exception. If it existed, another exception would be thrown since the URL is formatted wrong. The catch would show the exception. This is the same catch as the one from open file. So we have one catch for various exceptions. This marks the end of lecture 10. Thank you.